So the question becomes now, what if we're asking for the percentages, but it doesn't neatly fall into those lines, like above 1 standard deviation or below 2 standard deviations? What if it's somewhere in between? So we need a way of dealing with that. So what you can do is calculate something called a z-score. And a z-score, there's a formula for it. I'll give it to you. This is what it is. It's basically the number of standard deviations, the x value lies above or below the mean. Above or below the mean. So far I've been giving you easy ones where it's either 1 standard deviation or 2, but what if it's like 0.2 standard deviations above the mean? So the formula here is the z-score is x minus x bar over the standard deviation. So how far away is your value from the mean? And then you divide by the standard deviation. So for example, in part A from previously, if I calculated the z-score for that, can you tell me what it would be before I even do it? For part A in the last example from the previous section from before, when we wanted the percentage less than 2 standard deviations, what would the z-score be? Let's find out. So the score was 160, right, on the firefighter exam. So you subtract that from the mean, which was 200. And what was the standard deviation? It was 20. From the firefighter example we did previously, the mean was 200 and the standard deviation was 20. So I gave you this. It looked like this notation. The mean was 200 and the standard deviation was 20, right? That's x bar, that's the standard deviation. So you would just do that. You would get negative 40 over 20, which is negative 2. So the z-score makes sense. And what you can do is with that, you can, if we look it up in what's called the standard normal table, look in what's called the standard normal table, it will tell us what percentage of the values. Even though we already knew the answer, I'm going to give you one where we don't. So look in the standard normal table. So that's on page, I'll put it under it's on page 759. So if we look there, and I'm going to put it under the projector here, we're looking for the z-score of negative 2. So let me show you how to use this. Negative 2 is right here, negative 2.0, negative 2.0, and do you see this 0.0228? That means so let me write that number down. So z is negative 2.0. Does everyone see what you're matching up? Negative 2.0, 0.0228. So 0.0228, which means 2.28%. And what did we get? What did we say was the percent less than 160? 2.5, right? So that is close enough for stats. That's plenty close enough. So you see, so this works for anything. So let me give you a completely new example, and we'll use the standard normal table. Let me zoom out for a second. Let me give you a complete example. We'll tie it all together, hopefully. Okay, credit card debt for college seniors. Credit card debt for college seniors, you're told is normally distributed. So here's the symbol for normal distribution. The mean is 3,450. That's the mean, and the standard deviation is 1,175. So again, that's X bar, and that's the standard deviation. The question is, find the probability that a student would have debt less than equal to $3,600. So that's just notation. Find the probability a student would have less than equal to $3,600. So intuitively, do you think it'll be more than 50% or less than 50%? Why say more than 50%? Well, you're right, because the mean, if it's normally distributed in the middle, is 3,450. What we're looking for is all of them that are less than, right, 3,600. So we're looking for this area, and so of course it's more than 50%. So that's a good intuition. Okay, so all we do is you're going to compute the z-score using the formula I gave you. So you'll take the value 3,600, subtract from the mean using the formula I gave you, divide by the standard deviation, and you get 0.1277. And all you do is, that's the number of standard deviations above the mean. It's not even a full standard deviation, it's 0.1277. You look this up in your table and we'll have the answer. So I want to know the probability that z is less than equal to 0.1277. So I'll show you. I'm going to put the table under here and we'll have our answer, and then we'll write it as a sentence, 0.1277. So looking here, 0.1, it's a very small, it's somewhere in between. Let's see, this table actually doesn't even break it down to small enough numbers for us to see it here. So I'm just going to tell you on this one that it would end up being 0.5398. And so you would write as a sentence, you would write the probability a randomly chosen senior has credit card debt less than 3,600 is 54%, approximately 54%. So the probability a randomly chosen college senior has credit card debt less than 3,600 is 54%.